Selamat sore semuanya. Assalamualaikum warahmatullahi wabarakatuh. Kali ini kita masih lanjutkan kuliah statistiknya dengan introduction ya, penggunaan statistik di berbagai bidang. Nah, sebenarnya ada materi PowerPoint-nya, tapi kali ini yang 1 jam ini saya akan banyak memutarkan film saja ya. Jadi ini materi yang kemarin sudah sempat kita bahas tentang statistik deskriptif. Nanti materinya akan saya berikan dan akan saya bahas lebih detail di Selasa depan. Nah, kali ini kita akan banyak lihat film saja. Sudah saya pilihkan di YouTube ya. Nah, mari kita lihat film yang pertama ya.
See this guy? He is afraid for his life. This drawing is an 1832 joke. It's a riff on how nobody knew how to prevent cholera. You might suspend a chorus over your masked mouth, or wear a copper breastplate and tie pitchers of water behind your calves. Anything to keep the disease away. Starting in the 1830s, cholera pandemics swept the United States.
Nah, ini film ini tentang pandemi kolera di Inggris pada tahun 1830-an ya. Nah, 1832 ya. Nah, dan menariknya ini ada seorang dokter yang menggunakan statistik walaupun saat itu tidak dia sebut sebagai statistik rencananya ya. Yaitu Dr. John Snow ya.
Kingdom. Nobody knew how the disease was transmitted. Germs weren't an established idea. One London doctor, John Snow, tried to find out how the disease spread, and today, one of his investigations is iconic in the field of epidemiology. And it all centered on a pump. This is a map John Snow made to prove his solution to the cholera mystery in London. It also shows the confusion and the problems he was up against. Each of these bars represents a death from cholera. The disease often killed half the people who got it. It caused vomiting and diarrhea. The rapid loss of fluids was fatal. At the time, a lot of people believed cholera was transmitted in a miasma. Imagine an evil cholera cloud. This typical map from the 1840s shows a cholera mist that was blamed for transmission. Snow suspected a different source. At the time, people usually didn't get water directly in their homes. It came from a neighborhood pump connected to one of the few water companies in the city. John Snow mapped different water companies' service areas in London. You can see how they are occasionally separate and occasionally overlap. If a common pump was contaminated at any point, at the source or near the pump, Snow believed the water could kill. In 1849, he wrote that his study of symptoms and specific cases had led him to suspect the emptying of sewers into the drinking water of the community caused outbreaks, not a miasma. 5 years later, he had a chance to prove it and stop a fresh outbreak in the process. In August 1854, 20 people lived here at 40 Broad Street, including an infant who died of cholera. After her death, Snow started to investigate the outbreak. He didn't think the original water source was the problem, but he thought something might be wrong down the line, at the pump. He took samples of the water. They seemed clean, but he wasn't satisfied because more people were getting sick. He asked questions up and down the street where one man had noticed a bad smell from his water. Snow asked the registrar for a list of people who died. He started going house by house to interview the survivors, and many of the dead had taken water from the pump. He became convinced the Broad Street pump was the common link among the dead. He wrote, "I had an interview with the Board of Guardians of St. James Parish on the evening of Thursday, 7th September, and represented the above circumstances to them. In consequence of what I said, the handle of the pump was removed on the following day. People stopped using the water." But Snow had not won yet. Newspapers reported the streets were covered in lime. The city was using it as a powerful disinfectant on the streets. That showed they weren't fully convinced the pump was the problem. They still suspected miasma, so Snow bolstered his case through investigation and recording. He learned the 18 workers who died at this factory had drunk from big barrels of water drawn from the pump. At the same time, unlikely survivors could serve as proof of Snow's theory. According to miasma theory, this place would have been covered in cholera clouds, affecting all workers. But Snow learned the workhouse had its own well. No bad water got in. The same went for this brewery. That's because Snow learned the workers there drank from the brewery's water supply, or more likely, only drank the free malt liquor they got on the job.
That's right. Drinking on the job saved their lives.
Snow strengthened his argument and his map. He adjusted the location of the pump to show how close it was to 40 Broad Street and drew a dotted line. He showed a zone where it would be closest to walk to the Broad Street pump rather than another one. That zone is where most people died. He tabulated every death by date to do it. This was paired with a local reverend's similar data-driven investigations. A local surveyor looked at the plumbing at 40 Broad Street, where the infant had died. He learned that the cesspool, where sewage collected, was poorly designed and lined with decaying bricks. When the infant's diapers had been washed, the cholera-carrying water had leaked into the Broad Street pump supply. John Snow died in 1858. His obituary read, Dr. John Snow, this well-known physician, died at noon on the 16th instant at his house in Sackville Street from an attack of apoplexy. His researches on chloroform and other anesthetics were appreciated by the profession. At the time, Snow was more famous for stuff like a chloroform inhaler than a map. It took years for the investigation of John Snow to become an example for subsequent outbreaks and epidemiology textbooks, and it slowly, eventually, helped end the miasma myth. That's because Snow did not just make a map of a city. It's a map of his process and the field it shaped. It gave direction to a world where disease didn't have to be hidden in a cloud. Instead, it could start at a pump.
Ya, itu adalah kisah tentang John Snow, seorang dokter yang berhasil menghentikan wabah kolera dengan membuat suatu peta. Dan ini adalah contoh dari penggunaan statistik ya, di mana diberi konteks, yaitu dikasih peta, kemudian dari sana dia bisa memprediksi sumber dari penyakitnya. Ya. Nah, itu contoh yang cukup menarik. Ya, jadi statistik adalah ilmu ketika kita mengambil data, kemudian mengorganisasinya, dan kemudian dari sana kita mendapatkan suatu informasi ya. Jadi bentuknya bisa bermacam-macam. Itu adalah contoh yang sangat sederhana sekitar 200 tahun yang lalu ya. Kemudian saya lanjutkan dengan sebuah film yang lain. Saya cek dulu sebentar. Oke. Nah, ini film berikutnya juga bagaimana statistik yang awalnya tidak dipandang, tiba-tiba ternyata cukup memberikan pengaruh ya pada dunia kesehatan.
Statisticians use shapes to reveal the patterns in the data. But we also use images of all kinds to communicate statistics to a wider public. Because if the story in the numbers is told by a beautiful and clever image, then everyone understands. Of the pioneers of statistical graphics, my favorite is Florence Nightingale.
There are not many people who realize that actually she was known as a passionate statistician and not just a lady of the lamp. She said that to understand God's thoughts, we must study statistics, for these are the measure of his purpose. Statistics was for her a religious duty and moral imperative. When Florence was 9 years old, she started collecting data. Her data was different fruits and vegetables she found, put them into different tables, trying to organize them in some standard form. And so we have one of Nightingale's first statistical tables at the age of 9.
In the mid-1850s, Florence Nightingale went to the Crimea to care for British casualties of war. She was horrified by what she discovered. For all the soldiers being blown to bits on the battlefield, there were many, many more soldiers dying from diseases they caught in the army's filthy hospitals. So Florence Nightingale began counting the dead. For 2 years, she recorded mortality data in meticulous detail. When the war was over, she persuaded the government to set up a royal commission of inquiry and gathered her data in a devastating report. What has cemented her place in the statistical history books are the graphics she used, and one in particular, the polar area graph. For each month of the war, a huge blue wedge represented the soldiers who had died from preventable diseases. The much smaller red wedges were deaths from wounds, and the black wedges, deaths from accidents and other causes. Nightingale's graphics were so clear, they were impossible to ignore.
The usual thing around Florence Nightingale's time was just to produce tables and tables of figures. I mean, absolutely really tedious stuff that, unless you're an absolutely dedicated statistician, it's really quite difficult to spot the patterns quite naturally. But visualizations, they tell a story. They tell a story immediately. And the use of color and the use of shape, can really tell a powerful story. And nowadays, of course, we can make things move as well. Florence
Ya, yang menarik adalah Florence ini seorang nurse ya, perawat yang kemudian dia mencatat karena dia senang dengan statistik, dan kemudian dari sana dia membuat grafik ya. Grafiknya itu menjadi cikal bahwa statistik itu bisa meaningful ketika dia diolah dan kemudian divisualisasikan ya. Nah, coba kita lihat kisah ini dalam perspektif yang lain ya.
Florence Nightingale on big data. It might sound like a random pairing, like Marie Curie on WikiLeaks or Charles Dickens on twerking, but it isn't. We know her as a nurse, the lady with the lamp, gliding through blood-soaked army hospitals. But maybe we should call her the lady with the bar chart, because she was at least as illuminating in the world of statistics. So, what would she think of big data? Florence loved statistics. She said she found them more enlivening than a novel. And a friend said, however exhausted Florence might be, the sight of long columns of figures was perfectly reviving to her. For Florence, statistics were God's work. She said, to understand God's thoughts, we must study statistics, for these are the measure of his purpose. So, although she's famous now as a nurse, she actually trained first as a statistician. It wasn't until the beginning of the 1840s, when she was in her early 20s and saw hunger and unemployment all around her, that she became a nurse. She'd combined her nursing and statistics to become an experienced hospital manager just in time for the Crimean War. At the time, nurses were seen as ignorant and lower class. But Florence changed that. Florence volunteered to lead a team of nurses in the war. Before she arrived, the military hospitals didn't even bother to record many of the deaths. Florence collected data about everything, so she could show that changes in diet and sanitation had brought the hospital's death rate down from 42% to just 2%. It's only when you gather data methodically that patterns emerge. Things that were hidden suddenly become clear. That might sound obvious now, but it wasn't back then. Florence's work made a huge impact and laid the groundwork for things we now take for granted, like being able to compare hospitals' performance, or just the fact that hospitals are clean. Florence showed what could be achieved by following the evidence, instead of gut instinct, prejudice, or tradition. Another little-known side of Florence is her talent for infographics. She turned data into pictures, making it impossible for MPs and civil servants to ignore. So, she would love the data journalism we have today. She would...
Oke, ya. Jadi itu impact dari Florence ketika dia kemudian membuat suatu grafik dan ternyata itu membuka hal yang lebih dalam ya dari sekedar statistik ya. Nah, dengan perkembangan yang luar biasa, teknologi yang luar biasa, maka statistik sekarang sudah menggunakan data yang luar biasa banyak dan hasilnya lebih powerful ya, seperti di film.
I've spent my life working with stats, but I'm still amazed by many of the practical applications of statistics. Take language, for instance. This is a field that at first glance doesn't seem to have very much to do with numbers at all. But at Google's California headquarters, computer scientists are overcoming the world's language barriers with statistical machine translation.
We wanted to provide access to all the web's information, no matter what language you spoke. There's just so much information on the internet, you couldn't hope to translate it all by hand into every possible language. We figured we'd have to be able to do machine translation.
What the computer is doing when he's learning how to translate is to learn correlations between words and correlations between phrases. So we feed the system very large amounts of data, and then the system is seeing that a certain word or a certain phrase correlates very often to the other language.
Google's website currently offers translation between any of 57 different languages. It does this purely statistically, having correlated a huge collection of multilingual texts.
The people that built the system don't need to know Chinese in order to build a Chinese to English system. They don't need to know Arabic. But the expertise that's needed is basically knowledge of statistics, knowledge of computer science, knowledge of infrastructure to build those very large computational systems that we are building for doing that. Okay, so then I'm going to invite...
I hooked up with Google from my office in Stockholm to try the translator for myself.
I will type some Swedish sentences.
Okay.
Sveriges guldring I örat.
Okay, so it says Sweden's finance minister has a ponytail and a gold ring in your ear. So I guess it probably means in his ear.
Correct. It's amazing. He comes from the Conservative Party. That's the kind of Sweden we have today. I will type one more sentence. Sitt samköna partnerskap, nya biskop.
In his same-sex partnerships has Stockholm's new bishop and his partners a 3-year son. That's
It's almost perfect.
unusual.
At least one important thing, it's her. It's a lesbian partnership.
Okay, so that's those kinds of words, his and her, are one of the challenges in translation to get really those right
And
in
especially
MT.
when it comes to bishops, one can excuse it.
Right. So that, I guess more often than not it would probably be a his.
I will write one more sentence.
När Sverige deltar i olympiader är målet
Inte att vinna utan att slå Norge.
Okay. When Sweden is taking part in Olympic goal is not to win but to beat Norway.
Yes, this is what it is. But they are very good in Winter Olympics, so we can't make it, but we are trying.
Ya, sekarang dengan menggunakan kekuatan dari komputasi dan algoritma AI ya, seperti machine learning, data science digabungkan dengan machine learning menghasilkan suatu terobosan-terobosan yang luar biasa ya, seperti misalnya automatic translator ini. Baik, ini bentar saya setting dulu, ada masalah di suara kayaknya. Ya. Jadi kita bisa melihat dari beberapa film tadi bahwa mula-mula sangat sederhana, kemudian dia menjadi semakin canggih dan beragam ya, dan kemudian dia bisa menjadi menghasilkan sesuatu yang baru ya, dengan perkembangan jumlah data yang semakin banyak dan komputasi yang semakin bagus ya. Nah, mari kita lihat yang berikutnya, film berikutnya. Jadi Anda tadi sudah melihat pentingnya data diberi konteks, kemudian visualisasi, dan kemudian kita bisa melihat teknologi di mana dengan korelasi bisa didapatkan suatu informasi yang menarik. Nah, kita lihat sekarang teknologi masa kini ya.
This is kind of wild. Will a robot take my job is one of the most Googled questions. It kind of makes sense. You know, when phones were first invented, there was probably horse messengers freaking out all over the joint. Vinyl's making a comeback, but fidelity aside, why bother when you can have a curated playlist with thousands of songs right on your phone? Come to think of it, I can't tell you the last time I shot a film on film. See, change makes people panic, but things evolve regardless, so we accept it, we move on. And now that we're entering the so-called fourth industrial revolution, yeah, automation's gonna replace some jobs, but it will also create new ones and probably give rise to industries that never existed. That's the topic some of these next folks are exploring, how machine learning is making things more productive, more efficient, safer, and cleaner.
And cut.
That felt okay. You wanna go again?
No, we're set.
Okay.
Maybe just step back on that mark. Yeah.
Okay.
That's good.
Right. Yeah, I think I get it.
The trucking industry is at a crossroads. E-commerce is driving demand for shipping higher than ever. But the harsh realities of long-haul trucking are sending professional drivers looking for other work, leaving a 50,000 driver shortage in the U.S. alone.
There are, of course, some industries that will be impacted by AI in terms of labor workforce being diminished. But there are some industries that don't have the workforce to sustain it. And so that disconnect, that's where AI can fit in very nicely.
My name is Maureen Fitzgerald. I've been driving trucks for 32 years, and I was ready to make a change. 3, 2, 1.
Engaged.
Approaching retirement, Maureen saw automation coming and assumed it would replace her. She was partly right. Automation is coming, but her job won't be lost. It will evolve.
I've been in this career a long time. I've seen how everything has been changing. The monotony of coast to coast and the pay being low, and you're sleeping in a sleeper, you're sleeping at a truck stop. It's hard. It's a hard life. I saw an ad for a test driver, and I said, that has to be the perfect job.
Okay, but this isn't just about Maureen. We've all heard about self-driving cars, but self-driving trucks, why are they setting the pace of the autonomous driving industry?
We already have robotic airplanes. Most airliners fly themselves. But self-driving cars are a harder problem because the roads have a lot more things going on than the air does. And driving on the freeway is much easier than driving in the city. So we will see fleets of automated trucks, I think, long before we see self-driving cars in the city.
The company of Too Simple starts with a dream. A dream that we wanted to build the AI technology for autonomous trucks.
Can you give me one full rotation to the right? The truck was originally not made to be automated. Okay, can you give me 50% throttle? We add our intelligence, the servers, and all the sensors to make this work.
We're in the sleeper of a Too Simple tractor. We have removed what normally would be beds and refrigerators, and we've added our computer, which is the brains of the AI.
Driving a car is what is called an AI complete problem. If you solve it, you solve every other problem in AI However, to solve it, you need to solve every problem in AI. So it requires vision, it requires robotic control, so it requires motion and navigation, but it also requires social interaction with the other drivers. So at the end of the day, in order to drive a car well in the city, you need everything. It requires an enormous amount of common sense.
Common sense. That's what Maureen is doing here. Overseeing the AI truck as it learns to navigate real-world conditions, ready to take over if anything goes wrong. Today, they're taking a 10-mile loop to test scenarios that a human driver might encounter. Can this 10-ton vehicle safely navigate a busy freeway? Can it merge and change lanes?
3, 2, 1.
Autonomous driving started.
My name is David Ruggiero, and I'm a test engineer with Too Simple. My job is to let her know what's happening. Let her be absolutely comfortable the truck is doing what it's supposed to do. Gear change. There we are. When the vehicle is engaged, she is fully aware of what's going on around the truck, but she doesn't have to touch anything. I see
Right.
clear on the right.
Clear, not clear on the
I
left.
see the left approaching.
Never is one drive or one day ever the same. Left is now clear. Second I go. We're good.
Come on.
The truck was cautious.
So I'm still seeing full braking.
It was probably overly cautious. Let's go manual.
Yeah, we can do that.
Autonomous driving off.
Here we go.
Oke ya, jadi itu yang sekarang sedang rame adalah AI untuk autonomous driving, dan kita tahu itu machine learning-nya cukup intensif ya, dilatih dan juga dengan data yang sangat besar ya. Sama dengan automatic translation tadi, data itu menjadi bahan bakarnya atau dari AI ya. Jadi AI itu dari programming, data science itu adalah preparing the data itu. Dan kalau datanya cacat, ya hasilnya akan berbeda. Nah, itu kita melihat bahwa penggunaan statistik, kemudian untuk big data analytics dan data science itu berkembang sedemikian cepat ya, dengan kondisi saat ini di mana sensor-sensor dan kemudian data itu bisa didapatkan dengan lebih otomatis dan dalam jumlah yang sangat besar. Nah, mari kita lihat penggunaan AI dan data tadi pada kasus yang berbeda.
A whole new automated world still hard to imagine? Maybe it's more about what we're gaining than what we're losing. Will automation make things faster? More efficient? More productive? Tastier?
I've been making pizza for 15 years. In my life, I've probably made 2 million pizzas. So coming to Zoom was awesome because it was like, wow, this is different than any other pizzeria.
So I got the idea for Zoom about 7 years ago when I realized that Big Pizza was built on one central conceit, which was that there wasn't a better way to do it. I thought, I wonder if there's a better way to do it.
Big Pizza. Doesn't have the same ring to it as big data or big pharma. But it's not just about pizza. It's also about big waste. Last year in the US, about $200 billion worth of food was wasted. $200 billion. That's a lot down the drain, and also up in the sky. Waste is a huge contributor to greenhouse gas emissions.
Perhaps half of all food that's produced in the world is wasted. Artificial intelligence can help us change the supply chain so that they're much more efficient. We can have an impact there that already has huge, huge implications.
One of the classic tensions in every food business is producing too much and having waste, or not producing enough food and having stockouts. It takes years and years of practice for a human to forecast that, but that's actually a data problem that machines, and AI in particular, are really, really good at getting right. So at its core, Zoom is a fundamentally new logistics model. We predict what we're going to sell before you even order. And that whole predictive layer of the business is all driven by AI.
When Zoom first called me, I obviously thought, why on earth does a pizza company want a chief technology officer? But then when I heard the vision, the fact that we were going to be able to change an industry by focusing on this amazing end-to-end platform, which just happens to also produce amazing pizza, then it made sense.
To disrupt Domino's, Zoom uses machine learning to try and forecast how much pizza people want, what kind, and when. It crunches dozens of different variables: location, day of week, weather, what's on TV, past ordering trends, and then predicts how many Sergeant Pepperonis San Francisco will want on a Tuesday, for example.
Our supply chains are incredibly inefficient. Our food processing systems waste a lot of food. If we could improve predictions, we could eliminate most of that waste. We would know what the demand was going to be, where the products were going to be, and ultimately, that would make us all better off.
Absolute perfection would be no pizza gets wasted, and anytime a customer looks, there's always one of the type of pizzas they would like available. So it's an optimization problem. How close can you get?
Optimization, right. But what else? End-to-end is not just about prediction. It also involves automation or cooking.
Pizza and robots, very exciting concept.
Pepe and Giorgio, they dispense the sauce. We have Marta here, who spreads the sauce on the pizzas.
So we're still on Veggie Supremes, guys. These are looking good.
And down here at the end, we have Bruno, who helps deliver the pizza from the assembly line to the ovens or around the bypass. And in the back, Vincenzo, who helps load the pizzas onto the cartridges.
Based on its algorithm, the AI predicts how many pizzas and what kind to load onto the mobile kitchens. When orders come in, it also decides which mobile kitchen will bake it and exactly when to put each one in the oven.
Every single pizza has its own cooking profile and recipe. So each one of these ovens actually is a robot. They're connected to cloud services. They're always monitored, making it possible for one person working in here to cook up to 120 pizzas an hour.
It's humans and technology working together. It's pretty awesome. And that and the pizza. I love pizza. Pizza is like one of my favorite foods.
We use AI and simulation around how do we get the right delivery estimated time of arrival. The AI can suggest, here's the best place to put a truck so we get the hottest, freshest product to our customers.
We have a barbecue chicken, barbecue. When we get the orders, our system controls the ovens, which controls the cook time and how long the pizzas need to cook.
The AI can change the workflow on one of our vehicles to make sure the pizza's cooked at the last moment.
And then the system chooses which driver to send it to.
It's algorithms plus, it's AI plus humans, not AI instead of humans.
Now we have a pineapple that is ready to go. Their predictions for the amount of pizza that we carry on the truck are pretty spot on. Last Supreme of the night. Sometimes we'll have a bunch of pizzas left over by the end of the night, and we'll think the prediction was probably wrong for today. Then, boom, an order comes in, and the next thing you know, another order comes in, like 8 pizzas at once.
All of that data gets fed back into the learning algorithms, so every week we're trying to evolve our learning algorithms to do a better job than the week before. Part of what we're optimizing for is reducing waste. Maybe if you could use prediction to go back into the supply chain and predict more accurately what you need to grow and where you need to get that product, I think you can fundamentally change things.
Ya, itu jadi penggunaan untuk predictions, ya. Statistik banyak sekali dipakai untuk predictions. Tadi bisa melihat korelasi, bisa untuk memprediksi juga masa mendatang, ya. Di sini contohnya adalah bisa. Jadi kita sudah melihat berbagai penggunaan dari statistik yang luar biasa, bahkan di seluruh sektor, ya. Nah, sekarang bagaimana dengan engineering ya, terutama dengan hubungannya dengan kita? Apakah penggunaan data dan statistik nanti akan sangat penting? Nah, tentu saja ini sangat penting ya. Jadi sekarang juga teknologi untuk mendesain itu sudah menggunakan data dan kemudian dibikin menjadi suatu yang otomatis ya. Tentu saja manusia masih men-set up parameternya atau membuat goal-nya. Tapi mesin kemudian melakukan simulasinya lebih banyak dan lebih cepat ya.
Generative design lets you design things that weren't possible to design before. So the convergence of cloud computing, new materials, advanced manufacturing, and these new generative design tools are opening a new world up for designers to think and explore designs that really couldn't be done before. You speak in the language of goals and constraints. Basically, you frame the problem in terms of what you want the function to be of a design, and the computer generates objects to fulfill those designs. You get ideas out of left field as a designer where you're like, I would have never gone that direction. That's really interesting. I'm not sure if I even want to pursue it, but this is opening up my space of possibilities. The HackRod project, so we just took an off-the-shelf race chassis and put 56 sensors on the tension points of the chassis. The HackRod team drove that thing out in the desert under extreme conditions.
From there, that data was analyzed and input into one of our generative design systems, Dreamcatcher, and a new chassis was grown.
So this is one of the first times that data has been able to be gathered in the field on performance, fed back into the design to improve the design. So that's really a groundbreaking exploration.
As these things become easier, there are going to be more entrants in every market. 3 kids in a dorm room can start a car company. And what does that mean to the traditional car manufacturers? It means that they've really got to be looking at how they can start to adopt this stuff today.
The human brain can hold 5 or 6 variables at a time. The computer doesn't have that limit. So with generative design, what you're trying to do is put all these conflicting and dependent variables together, have the computer think about what are the optimal options, and present those back to the user. What I really think is unique about the elbow chair is that we're considering the manufacturing in CNC. So rather than taking everything to an additive output, putting constraints in for CNC machinery for milling was an important part of just realizing a beautiful and functional design, and using wood as a material just had a beautiful aesthetic output. What are the goals and constraints? Well, there's some weight, there's the balance, there's do you want the chairs to be able to stack? Letting the computer decide and give you hundreds of different options on that fit your preference, including the materials that you intend to build, I think was just a great creative expression in furniture design.
Ya, itu adalah ilmu yang sedang berkembang. Kalau Anda tertarik dengan struktur ya, ke depannya Anda bisa mendalami generative design ini ya. Generative design ini kita memasukkan beban-beban di setiap titik dan kemudian komputer akan menghitung atau membuat desain konstruksi yang paling tepat ya. Dan uniknya dia bentuknya jadi seperti biological ya, jadi seperti tulang otot itu bentuknya kan sangat efisien ya, sangat efisien, ringan tapi kuat ya. Nah ini kita lihat aplikasinya untuk
The search for life in the solar system is expanding beyond Mars to the outer planets like Saturn and Jupiter and their moons. We really require greater and greater amounts of fuel to propel us into those areas of space.
Spacecraft are some of the highest performing and best engineered things that humans have ever designed. The way we're going to reach farther out into the solar system, the way that we're going to find life if it's out there, is by using better and better technologies.
Every bit of mass that you can save on the launch vehicle means you can put more scientific instruments on board.
For every 2 pounds saved on the structure of the lander, almost 1 ton is saved in the launch vehicle. It gives us an opportunity to answer one of the hardest questions of our lifetime, which is there life outside of this planet?
The goal of this project has really been to reduce mass and enable the lander to go further and further into space.
We've been working very closely with NASA's Jet Propulsion Laboratory to explore new concepts in how we can design interplanetary landers. What's really exciting about this project is this is the biggest and the most complex thing that's ever been done in generative design.
Initially, the engagement was somewhat of a curiosity in terms of research for them. They were excited about potential 10% mass savings. That's on the order of what they can do. Everyone was surprised when we were able to demonstrate 35% mass savings. That really opened up a whole new range of possibilities.
This lander, this whole assembly, really pushes generative design to the very, very limits of what it's capable of. We're working with JPL to really develop the tools of the future.
Traditionally in design, you would go through a manual process of identifying your components, identify where the components are located, and then building structure around that. With generative design, we identify the critical pieces and locate them so we can actually optimize for, say, packing a payload.
For this kind of structure, the benefits that generative design provides are not simply about weight saving. They also allow engineers to much more quickly iterate on the design process. It allows the design to be more flexible and for introducing more design intent into the problem definition.
With generative design, it gets to open up your mind. You start looking at these problems saying, wow, that's a really interesting way to do that. Now I got to figure out how to manufacture it.
You can see examples of generative design in additive, in subtractive, and also in casting. The ability to really leverage that problem definition up front allows us to do a plethora of design options rather than just reduce one design down to its most optimal form.
Applying these new generative design technologies to such a high performance and important problem is something that's tremendously exciting, and it's going to be these technologies that let us get out there.
We've really pushed the limits of mass reduction, and that's significantly magnified when you think of how much fuel or how much more science we can fit into that lander. The things we're working on today at Autodesk can really inspire in that search for life beyond our Earth.
Ya, itu tentang generative design yang tadinya hanya diharapkan menghemat 10%, ternyata bisa sampai 30-35%. Jadi itu luar biasa ya. Itu di struktur. Misalnya kita lihat juga misalnya di CFD ini ya, ini sedikit agak beda lagi. Jadi ini misalnya untuk merancang sepeda.
So what we are showing specifically here is a demo that shows how we can accelerate simulations by learning them. Our program is based on a machine learning system that learns to develop an intuition about the laws of physics. We get a database of simulations or of physical measurements from a wind tunnel, for instance. We feed these simulations to our software, and it learns to reproduce the simulation directly by looking at a mesh representation of the input. This is the bike. And using our software, you can explore much more exhaustively the space of designs. So here you can see inside there is the radar. Here's the radar model, and you want to find the shell around this radar, which has the best aerodynamic coefficients. So the bike raced for its first time on last September. Since it broke the French record. From the French record to move now to beating maybe the world record next year.
Ya, itu digunakan untuk aerodynamics. Ini ilmunya Pak Pram ya. Kalau Anda tertarik dengan aerodynamics dan kaitannya dengan machine learning dan AI, nanti Anda bisa belajarnya ke Pak Pram ya. Nah, itu menarik, dan mengapa ini penting, karena makin lama ini makin signifikan ya di dunia aerospace ya.
Can something fly thousands of hours before it takes off? Be laid out and assembled hundreds of times before any metal is even cut? Can something be designed, built, and tested not by thousands of people, but by fewer than 200? using leading-edge design tools across a digital landscape connected virtually across the globe? It can. It was. Introducing the Department of the Air Force's new E-Series, a revolutionary approach to creating E-planes, E-weapons, and E-satellites, all of which are to be designed digitally and built virtually before they take to the skies. The proof? The T-7A Red Hawk jet and advanced pilot training system, the first in the new paradigm of how air and space dominance is designed, coded, and built. The new E-Series. What's next is what's now.
Nah, ini adalah dari Boeing ya. Sekarang Amerika untuk mendesain pesawat tempur generasi ke-6 katanya hanya kira-kira 1 tahun mereka sudah punya desain baru ya. Jadi sudah cepat sekali. Kalau dulu bikin pesawat mungkin bisa 10 tahun, sekarang 1-2 tahun sudah jadi. Dan ini pesawatnya sudah jadi. Ini didesain secara virtual, disimulasikan, dites secara virtual dulu. Setelah mendapatkan desain yang optimum, kemudian baru dibikin ya pesawat.
For takeoff. Acceleration. Set to prove out the Boeing T-7A in inverted flight, Boeing test and evaluation pilots Matt Giese and William Berryman are the first to take the advanced trainer, developed for the U.S. Air Force, through a rugged series of maneuvers, testing the jet's fuel system at all angles.
So what we do is we roll the airplane upside down, and we need to make sure that things like fuel, oil, everything else feeds properly to the airplane during this negative G testing.
Clear to maneuver, item 960. Cutting through the skies over Missouri, the agile advanced trainer lines up for the first crucial test point as a chase plane follows. Okay, Bravo's visual, we're starting to close. Tally ho. On the ground, test engineers in the telemetry room monitor every system on the jet and give the crew the go-ahead to invert at high speed. Data's ready, verify chase in position. Chase in position. So here we go. 3, 2, 1, now. Rolling the jet over, the head-up display gives a pilot's eye view, icons spinning, as a cockpit camera captures the world turned upside down for the aircrew.
1, 2, 3.
We rolled to an inverted flight position and pushed to -1 G, so it's a little uncomfortable. You're kind of hanging in the straps in the seat.
10, 11.
You know, our task was to go fast and upside down. It went perfectly as scripted. It was flawless.
Rolling up.
Historically speaking, airplanes need to demonstrate the capability to operate for some period of time in maximum afterburner at maximum fuel flows at -G. This airplane met those requirements with flying colors.
Ya, ini contoh dari pesawat yang sudah menggunakan kemajuan dalam teknologi desain ya, sehingga bisa disimulasikan ribuan jam tanpa sebenarnya pernah terbang ya, pernah dibikin ya, baru simulasi. Dan itu tentu saja banyak sekali data ya. Nah, sekarang kita lihat kalau di aviation ya, aviation juga banyak sekali dengan perkembangan big data dan machine learning ya, dengan AI ya, itu contohnya adalah ini misalnya.
Without a human pilot was a question posed in an article in the New York Times that fueled a lively discussion on Facebook last year. Many people reacted emotionally, with comments in caps. Some users shared their knowledge about the aviation industry, while others said they were more prepared to accept driverless cars than pilotless planes, maybe because it feels safer to be on the road than in the air. Technologies like computer vision power the automation in self-driving cars. But are we close to commercial planes being controlled by AI systems instead of pilots? Prototypes of self-piloted passenger air vehicles by Boeing and Airbus have already done their first test flights. But for now, we can put aside futuristic scenes in which commercial airplanes fly without human control. It will take years of certification and testing before air travel becomes fully pilotless. The good news is that airlines do use AI, or rather data science and machine learning, to automate or speed up operations. So, we've chosen 5 real-life use cases that don't aggravate your aerophobia with AI phobia. AI and data science in aviation. Revenue management and route planning. A direct flight between Chicago O'Hare and the Polish city of Krakow by LOT Polish Airlines may strike you as overreach. Chicago and Krakow are both large airport hubs, but is that enough to run cross-Atlantic flights between non-capital cities? Well, yes. The Chicago metropolitan area is home to an estimated 1.5 million people of Polish descent. So the real demand for this city pair is high. Understanding traveler demand for specific city pairs and pricing flights are among the main problems airlines solve to survive. To do that, carriers must consider thousands of factors when analyzing data. While analysts still can use traditional statistical approaches, data science allows for more sophisticated ways to accomplish demand analysis. IATA suggests that airlines can use traveler behavioral data, abandoned searches on online travel agent, and meta search sites or social media chatter can help define leisure demand. Data from professional networking sites, recruitment, and procurement activities may signal emerging business travel destinations. In a 2017 showcase for airlines, Skyscanner used machine learning-based clustering to group about 50,000 origins and destinations by similarities. They considered about 30 parameters, like the month of travel, the time a reservation is made, how long people stay at the destination, and more. Some results are quite surprising. For instance, the cities that are traditionally considered best for romantic trips were as popular with single travelers, and the proximity to a destination may be more important than the city itself. On top of that, events like festivals, conferences, or expos drive short-term spikes in demand. So, revenue teams can rely on event data to raise fares for specific routes and dates to benefit from rising demand. Aviation Rank by PredictHQ uses ranking algorithms that match historical flight bookings with event data to reveal how much a given event may affect traveler demand. Qantas, the Australian flag carrier, is one of the provider's customers. In-flight sales and food supply. Imagine you're having an early morning flight. Challenging stuff. Once you've gone through airport checks and finally taken your seat, you might think about a cup of coffee and a sandwich, and a carrot cake looked tasty on a menu. But some people never order airplane meals, so the airline supply management specialists must estimate how many snacks and drinks they onboard to deliver to food eaters without being wasteful. Cabin waste is a serious environmental issue. In 2018, airlines generated 6.1 million tons of waste, most of which was incinerated or moved to a landfill. In spring 2018, EasyJet CEO Joan Lundgren tasked the data science team to analyze the demand for food items depending on a route. The team learned that demand for items on a 6 a.m. flight to Edinburgh is very different from that of a Friday night flight to Ibiza. So, EasyJet was throwing 3 fresh food items in the trash after each flight, or nearly 800,000 annually. Joan Lundgren noted that such a mistake cost the carrier millions of pounds. Eventually, data scientists created a new algorithm for demand prediction. The insights helped the airline save a significant amount of money and do the right thing for the environment. Fuel consumption optimization. Commercial aviation contributed 2.4% of global CO2 emissions from fossil fuel use in 2018. The percentage doesn't seem significant, but here is another fact. Carbon emissions increased by 32% over the past 5 years. That's why aircraft manufacturers and airlines are looking for ways to improve their fuel efficiency. The second big reason for carriers to reduce carbon emissions is a financial one. In 2018, airlines spent 23.5% of total expenses on jet fuel. That's a lot. To become more fuel efficient, an airline must accurately predict how much fuel it needs for every scheduled flight to supply a plane. The best scenario is to have a single analytical tool. Southwest Airlines worked on such a solution in its fuel consumption project. The The team developed 8 predictive models that included time series algorithms and neural networks. The system could produce 9,600 fuel consumption forecasts for each month and each airport the carrier flies to. Previously, the team generated 1,200 monthly forecasts, and each analyst spent up to 3 days to make one. The new solution does it in 5 minutes. It generates forecasts for a 12-month horizon and considers such influencing factors as fuel price, number of trips, and a time period. The predictions also became much more accurate. Boarding and checking bags with facial recognition. Facial recognition technology is about analyzing a person's facial landmarks for given purposes. Airlines use this biometric technology as a boarding option. The equipment scans travelers' faces and matches them with photos stored in Border Control Agency databases. These can be photos from passports, visas, or other travel documents. Here's how it works. Travelers first scan themselves and then their passports at self-service kiosks. Then proceed to check in their bags with a scanner too, and go through another facial scanner. Why is it needed? Government agencies such as the U.S. Customs and Border Protection stresses that the technology allows for creating a seamless traveler experience that's faster and safer. Numerous airlines are either piloting or already using biometric gates in selected airports. Delta is one of them. In November 2018, the airline opened a biometric terminal at the Atlanta airport. The airline claimed the terminal is the first of its kind in the U.S. Delta also noted it would start testing the technology in all 14 international gates at Detroit's McNamara terminal by mid-December 2018, and added that in 2019, customers will be able to use biometric boarding from curb to gate. In the summer of 2019, Delta introduced facial recognition in another Atlanta airport terminal, as well as in Minneapolis, Detroit, and Salt Lake City airports. That's 49 more gates equipped with facial recognition software. Travelers seem to like the new boarding option. Delta surveyed customers at Atlanta Terminal F and discovered, for instance, that 70% of them found the biometric boarding experience appealing, and 72% favored it over the traditional one. Preparing a plane for the next flight. Passengers sometimes have to wait at the gate to get on a plane when an aircraft isn't ready for boarding and departure. Maybe a catering truck is late, or the cleaning team is busy with a different jet. The time between an airplane landing and the next departure is called a turnaround. In 2018, U.S. passenger airlines were losing an average $74.20 per minute due to delays. The U.S. Department of Transportation calculated that delays caused by plane servicing accounted for 5.8% of all delayed flights. That's nearly 6 times more than flights delayed because of extreme weather. Zurich-based startup Asai provides software that processes video streams from airfields using image recognition algorithms. Neural networks that power the software recognize objects, movements, and interactions. Airline employees can monitor in real time how the plane is being prepared for the next flight, including fueling, cargo loading, or catering delivery. So, they can decide whether they need to take measures or not. Lufthansa Systems addresses the same problem with its deep turnaround solution. The IT service provider for the aviation industry opened its subsidiary, Zero G, to work on its AI initiatives. The solution also analyzes video data and updates users on what's going on during airplane services in real time. Airlines use data science and machine learning to evaluate passenger demand across different routes, use data insights to optimize aircraft ground handling and fueling, or they redefine passengers' airport experience with biometric boarding. With new distribution technologies, we may expect airlines to start personalizing offers for individual travelers based on their preferences and willingness to pay. Personalization is one of the priorities that IATA outlines. As for the AI autopilots, airlines are very conservative when it comes to new technologies that can directly impact the safety of flights. Carriers will likely wait until AI matures enough and until the traveling public is ready to trust it.
Ya, itu adalah contoh penggunaan di aviasi ya. Jadi kita lihat banyak sekali penggunaannya dan saya kira ini pengantar ya bahwa ilmu yang kita pelajari ini cukup menarik. Dan ini nanti akan kita bahas singkat, tapi Anda sudah tahu idenya. Jadi ketika kita mendesain suatu sistem otomasi, kita akan berhubungan dengan banyak data, dan bagaimana kita menyiapkan data itu supaya kemudian dia bisa diolah dan dipakai untuk memprediksi, untuk otomasi, dan untuk klasifikasi, dan yang lain-lain. Nah, salah satu yang penting ketika kita prepare data itu adalah bagaimana kita bisa mengevaluasi dengan visualisasi ya. Jadi ini ada berbagai teknik untuk visualisasi sehingga kita bisa melihat kondisi data dan bisa melakukan preparation ya. Ini akan kita bahas lebih lanjut Selasa depan. Nah, intinya adalah bahwa ada berbagai macam gambar, cara kita mengelola, contohnya ini ya. Ini kalau kita klasifikasinya terlalu sedikit, jadi seperti ini datanya. Kalau terlalu detail, malah jadi juga nggak ada manfaatnya. Tapi kira-kira yang bagus ya, ketika seperti ini ya, 12 ya. Jadi dibagi 12, sehingga kelihatan dia ada bentuknya, bobotnya ada di mana, kemudian skew dia ke arah mana gitu ya. Nah, hal-hal yang seperti itu ada juga yang pakai teknik box plot misalnya, ini akan mengetahui ada yang namanya data-data cacat yang disebut dengan outlier. Nah, itu ya, bisa membandingkan dari berbagai kondisi secara cepat gitu ya. Oh, ini misalnya sedan seperti apa, horsepower-nya, kalau sport itu seperti apa, dan seterusnya ya. Nah, itu bagian dari keseluruhan dari statistik ya. Nah, mungkin waktunya sangat terbatas, jadi saya ingin memberikan tugas ya. Tugas ini sebenarnya sederhana saja. Tujuan dari tugas ini adalah kalian membentuk kelompok ya. Kelompok itu maksimum 5 orang. Ya, jadi membentuk kelompok maksimum 5 orang. Nah, tugas ini sebenarnya bagian dari pembelajaran mandiri ya. Jadi supaya Anda juga melakukan suatu aktivitas, apakah itu dikerjakan bersama-sama, ataukah ada teman yang volunteer, tapi tujuannya satu grup itu belajar bersama ya. Nanti tugas itu ada nilainya juga, jadi sebagai bonus selain kuis ya, selain dengan ujian-ujian ya. Nah, tugasnya apa adalah tugasnya membuat suatu PowerPoint sederhana, membahas apapun, suatu kasus dengan data science yang menarik, engineering maupun manajemen gitu ya. Nah, silahkan Anda bahas, tadi sudah ada contoh-contoh apapun ya. Kemudian dibikin slide-nya misalnya 10-20 slide atau lebih sedikit juga nggak apa-apa. Nah, Anda bahas sebuah kasus, pilih saja apa ya yang Anda tertarik, grup Anda tertarik. Kemudian gunakan statistik deskriptif, Anda boleh nyontek juga dari sebuah video yang ada di internet ya. Nah, kemudian Anda crop aja, copy paste, screen capture, lalu ditempel-tempel, nggak apa-apa. Yang penting Anda coba explore bagaimana suatu kasus itu dibahas menggunakan statistik deskriptif, dan kemudian menggunakan gambar-gambar, dan mengapa gambar itu mewakili kasus tersebut itu. Jadi menarik begitu ya. Ya, nanti tugas ini akan kita bahas lebih detail melalui WhatsApp ya. Yang belum bergabung dengan WhatsApp, tolong kontak saya atau kontak angkatan 2019 ya, supaya bisa dimasukkan sehingga kita bisa komunikasi lebih intens di sana. Nah, kira-kira seperti ini tugasnya. Saya berharap minggu depan, paling lambat Kamis minggu depan itu sudah dimasukkan ya. Nanti saya bikinkan formnya, saya bahas lebih detail di WhatsApp ya. Baik, mohon maaf kali ini belum interaksi. Mudah-mudahan adik-adik terinspirasi melihat dengan banyaknya film-film seperti tadi ya, bahwa ternyata bidang data science ini luar biasa berkembang, dan manfaatnya juga saya kira sangat penting ya untuk disiplin ilmu yang lain-lainnya juga. Silakan kalau ada pertanyaan, kalau tidak ada ya saya tutup sampai di sini. Ada pertanyaan? Belum ada ya? Ya, baik, selamat sore semuanya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Terima kasih, Pak.